Hello everyone, welcome back to Science Icons once again. So today we have come up with a new video on a very new chapter. वो तो समझ आ ही गया होगा thumbnail देख के. So yes, our topic for today is radioactivity. This is radioactivity. Now, today's video is mainly based on important of the key points of radioactivity. I'll make a separate video where I will be going in details with radioactivity, but today is the things that you need to have the basic understanding and the things which usually comes in examinations, the easier parts that I am going to discuss today. But the detailed concept for that you will have a separate video. Okay. So if you have already, I will give the link of a video which I've already posted long back, 2-3 years back. There I have explained what is atomic number, what is mass number, isobar. These things I've already said there. So if you go through that video, the first part of the chapter is done. You have all about that. You have nothing extra. You have just the concepts, the basic concepts of atomic number, mass number, how to write it, what is isobar, what is isotone, these things are there. So you will understand if you go through that video. I'll give the link. Today's thing is actually about the very basic concept, that is radioactivity is basically nothing but disintegration of a substance by spontaneous radiation, emission of radiation such as uranium. Substances example: uranium, radium, polonium, thorium, actinium. These are the substances, and they are going or undergoing a decay. Why they are undergoing a decay? Because they are emitting radiations. So any substance which is emitting radiation from it will undergo decay, and this decay will actually be termed as radioactive decay. Fine. Now, radioactivity is a nuclear phenomenon. Why? Because first of all, it's a spontaneous activity. It cannot be predicted. If you change the pressure, if you change the temperature, if you give any physical condition or any physical change, electrons will jump from one shell to the other, bonding will take place, many things will happen, but only with electron. Nucleus is not going to be interfered. But uranium, polonium, radium, these substances, when it is kept in a container, we will find that spontaneously with time, the nucleus is emitting radiations. Those radiations is not getting suppressed or is not getting more activated. That is something which is solely dependent on it. We are no one to understand what is actually happening. Okay, we neither can change that radioactive decay nor we can enhance it. Whenever the nucleus want to emit that radiation, the nucleus will radiate out that particular particle. Whether it's alpha, whether it's beta, whether it's gamma, doesn't matter. But that will happen spontaneously. It will not get affected even if we change any kind of physical things which are around it, like temperature and pressure, etc. I'll just read one paragraph from the book and I'll tell you what are the keywords. Any physical change, such as change in pressure and temperature, or chemical change like excessive heating, freezing, action of strong electric and magnetic fields, chemical treatment, oxidation, etc., does not change the nature of radiation which is emitted by the substance and its rate of decay. I've already said this. This clearly shows that phenomenon of radioactivity cannot be due to orbital electrons, which would easily be affected by such changes. The radioactivity should therefore be property of the nucleus. Thus, radioactivity is a nuclear phenomenon and it is the process of spontaneous emission of alpha, beta and gamma radiations from the nucleus of atoms during their decay. The Rutherford experiment, properties of alpha, properties of beta, properties of gamma. For this we will have a separate video. For the time being, assume that you know what is alpha, that you know what is beta, and you know what is gamma. Let us assume you know. This is the basic thing you know about them. They are the radiations which is emitted from the nucleus of an atom. It is a nuclear phenomenon. It is a radioactive activity which is taking place here. So the radiations are getting emitted by the nucleus of the atom. Whether it's alpha, whether it's beta, whether it's gamma, that solely depends on the nucleus. We humanly, it's not possible to be those things to be get controlled or to control it, rather to enhance or to slow down the process of decay. It's not possible. Human, it is solely dependent upon the substance which you have taken. Fine. After this, the properties I've already said. I'm not going into it right now because for this we will have a separate session, a separate video. Now, if I come to one thing, that is, suppose you have a parent nucleus. Okay, you have a parent nucleus, and it is said that the parent nucleus is emitting alpha particle. So we have a parent nucleus. If you have seen my that video, you will understand that we write mass number on top, atomic number at the bottom. So superscript is my mass number, subscript is my atomic number. So I am representing mass number by A and let the substance be X. This is my mass number, this is my atomic number. What is it emitting? It is emitting alpha particle. Okay, know one thing, we write alpha particle in this way. This is the way we represent alpha. Beta is represented by this thing and gamma is represented like this. Alpha, beta, gamma. Okay. What it has emitted? It has emitted alpha particle. Okay. What is it emitted? It has emitted alpha particle. So it's alpha emission. जब भी alpha particle emit होता है, that means a daughter nucleus is going to form. The full composition of the nucleus is going to change. And the new daughter cell is going to be produced. My parent cell was X. Now my daughter cell became Y. This is just a convention. This is actually happening with the substances like polonium, radium, uranium, these things. For now I am representing by X and Y. So if my parent cell is, substance is X, it is having mass number A, atomic number Z, and if it is emitting one alpha particle, that is, it is radiating out alpha, that means a new daughter cell is going to form, and the composition of the nucleus of the new daughter cell is going to be A minus 4, Z minus 2. Now you will say, what has happened? Actually, this is going to happen if you take uranium in hand. Obviously, you will not take it directly because it's radioactive. But if you see uranium, it is happening. It's not something theoretical. It's actually happening. What is actually happening? That is, the mass number is getting reduced by 4. The atomic number is getting reduced by 2. So if, suppose for example, the mass number of X was 24, here it will become 20. And if the atomic number of X is 18, here it will become 16. After this, suppose it has emitted one more alpha particle. One more. So again minus 4, again minus 2. With this, what it will emit? It will emit alpha particle. What is alpha particle written as? It's helium-42. This is what alpha particle actually is. This is the nuclear composition. The nuclear composition of alpha particle is exactly similar to helium, right? The atomic number is 2 and it is unique. Atomic number for all is not same. If helium is having atomic number 2, no other element in this universe can have atomic number 2. Only helium can have it. So if alpha particle is having atomic number that is 2, that means it is helium. Because helium has its own unique identity, that is atomic number. And what is the mass number of helium? 4. The mass number of this was also 4. Henceforth we can say that this alpha particle which got emitted is nothing but helium. Now more details are there. For the timing to explain you, I have said this. But if you see my detailed one, which I will be posting soon, you will understand why it is helium. Okay. Now let us assume, again I am taking the same parent nucleus. The same parent nucleus I am taking, that is X. So again mass number will be A, atomic number will be Z. This time instead of alpha, it is emitting what? It is emitting beta. It is emitting one beta particle. What will happen here is, suppose the daughter nucleus here is again Y. Okay, let it be Q. the daughter nucleus. So the daughter nucleus, the mass number will not change. The atomic number will get increased by 1, and this is going to be, this is what? This one beta particle. Fine. So again I have taken the same perinucleus where my atomic number was atomic number was Z and mass number was A, and what it has released? It has released 1 beta particle. What is happening? The mass number is remaining same, but the atomic number is getting increased by 1. Why you know? Why you know? Because 1 neutron from the nucleus got converted to proton. 1 neutron from the nucleus got converted to proton. So we know what? Atomic number is equal to number of protons. If proton is getting increased by 1, we will have to add 1 here. And why this did not change? Because the net number of neutron and proton is constant. Which initially was a proton, in neutron, initially thing that was a neutron has now got converted to proton. But actual net number of neutron and proton is constant. That means we will have the same mass number, but 1 has to be added to the atomic number. Mass number will be constant. That means it will be same. And with that it will release 1 beta particle. Now you may say this is electron, but actually this is not electron. What is it? We will learn in my next video. But for the timing, understand this is not an electron. You cannot say that electron is getting released. It is not the electron which is present in the orbits. Okay. And what if gamma radiation takes place? Same perinuclei I have taken up, and now it is releasing gamma. If gamma particle is released or it is emitted, nothing is going to happen. Nothing is going to happen. Just 1 gamma is going to be released. So if gamma is released, just 1 gamma particle is going to be released, that's it. No change in composition of the nucleus. Fine? This is the basic thing. Council gives questions from here. Okay? In a question paper you will find, in 2 to 3 marks questions you will find given from here. You have few reactions given here, like with uranium, thorium. Just go through those things. Actual funda is this, nothing else. In that video, which I am going to, explain detailed version of this chapter, there I will also tell you about the isotopes of uranium. We have 2 isotopes of uranium, that is 235 and 238. More radioactive element is that where the number of neutron and the number of proton is having a huge difference. That is what makes a nucleus radioactive, where the number of neutrons and protons is having a huge difference. Okay, so 238 uranium should be much more radioactive in that way, but 235 is more radioactive than 238. This is one of the mysterious things. But don't worry, I'll tell you then why it is. But except uranium, in all other elements, if we'll have a greater version of the isotope, like for hydrogen we have protium, deuterium and tritium. In that case, tritium will become more radioactive because the number of neutron and proton, the difference between the 2 numbers is maximum in case of tritium, least in case of protium. Fine. Next, in part B, you have nuclear fission and nuclear fusion. Only one thing I'll tell about this and nothing else. Reactions also I'm not going to show you here. In that video, we are going to learn about the reactions. Just I'm going to discuss what is fission and what is fusion. The term fission and fusion, let me read out the definition. If fission is the process in which a heavy nucleus is getting split into 2 lighter nuclei nearly of the same size. That means from one nuclei it is getting divided to 2 nuclei. This is my fission. And fusion is just the opposite. We have 2 nuclei getting into 1. This is my fusion. Which is much more possible, which we use to produce or make atomic bombs. I will tell you. Bombs, everything I will tell you. Whether it's fission process or it is fusion process. Not now, but in the video which I am going to post soon. And reactions also I'm not going to say. Just one thing you know, this thing which is happening here in case of nuclear fission, we have to know one formula, that is E equals to mc square, given by Lord Einstein. This formula is given by Albert Einstein. E equals to mc square, which says that the mass of this particular nucleus is not equal to the mass of these two nuclei. If I add the mass of these two individual nuclei, then it will never be equal to the mass of the bigger nucleus. Now you will say law of conservation of mass is getting denied here, but no. Law of conservation of energy, mass, everything is followed, because the mass is getting converted to energy following this particular formula, where E represents energy, M represents mass, and C is the constant speed of light. That is 3 into 10 to the power 8 meter per second. That is the constant speed of light, and we have to spare constant speed of light. Okay. So this was all. Nothing else to be I want to tell right now. So just wait for the next one video to come. Then we will discuss in details. So this was all for today. Just wait for my next video, and to strengthen the concepts, these are the basic things which you generally require for attempting small questions. So till then, bye.